Welcome back to Algebra 1, Chapter 10, Section 4 in this book. We've been talking about polynomials, and that's where you have things like this that can't be added or subtracted because they don't have the same letters with the same exponents. And then we talked about how you can multiply two of them together to get one like that. So if you don't know how to do that, watch the tape before. This one multiplied together is that one. X times x is x squared. X times 3 is 3x. Negative 2 times x is negative 2x. 3x minus 2x is x. Negative 2 times 3 is negative 6. Remember, I told you that sometimes they leave it off, and sometimes they say equals 0 or y or f of x because they're weirdly the same thing. I'm going to explain to you a little bit more of why, weirdly, they're the same thing. And it's this. That what is considered the answer to this problem? Remember when we learned systems of linear equations, the solution, the answer, was where the two lines crossed each other. Well, with this, if it has a squared, then its shape is going to be parabola. And the answer is where it crosses the x-axis. Not where they cross each other because they don't. It's where it crosses the x-axis. That's considered the solutions. So, and where this is where y equals 0. The x-axis is where the y-axis is 0. Right there, 0. You don't go up or down on y. You stay where you are. So that's why y and 0 is the same thing. And the f of x thing, that shows that it's a function. Remember, if we take our pencil across it, we only touch it in one place, so it's a function. So sometimes you have that instead, the function notation. All right. Now, how do we solve this polynomial? If we had x minus 2 and x plus 3, and we would say equals 0, how do we solve it? Well, what we do is called the zero product property, and you take each one and set them equal to 0, because the parabola crosses at each place at 0, right? So we write x minus 2 equals 0 and x plus 3 equals 0. Now we solve for x. How do you solve for x? By doing the opposite. Why is x not alone? It's got a minus 2. What's the opposite? Plus 2. What I do to one side, I do to the other. Those cancel out. So one answer is x equals 2. And there it is. Done. That's where it is crossing the line. And the other one, we minus 3 to both sides. X equals negative 3. So the other place where it crosses is right there. Okay? So what about this one, where it's x plus 5 equals 0 squared? Well, we said last time that's x plus 5 times x plus 5 equals 0. If we set them both equal to 0, they're the same thing. So it turns out this one, instead of crossing in two places, it's only touching in one place. And that place, let me do that a little better, is x equals negative 5. So if we could see this graph, 1, 2, 3, 4, 5, there's a parabola sitting right there, touching just in one place at x equals minus 5. Okay? What about if you have 3 of them? Oh my! You do it 3 times. Not hard. 2x plus 1 equals 0. 3x minus 2 equals 0. And x minus 1 equals 0. So, why is x not alone? It's got a 2 and a plus 1. You work from the outside in, so we get rid of the plus 1 first by doing minus 1. 2x equals negative 1 divided by 2 divided by 2. X equals negative 1/2. And plus 2, 3x equals 2 divided by 3 divided by 3. X equals 2/3. And plus 1, x equals 1. So this one, because it's got 3, remember I told you they get weird shapes after square? This thing is actually crossing in 3 places. And it's got 3 answers here. Now, Let me show you one more thing before we move on. I showed you the math, but really you can kind of shortcut it because this ended up being the opposite sign of this. My answer was, this is minus 2, it was plus 2. Plus 3, it was minus 3. Okay, so look at this one, it was plus 5. The answer ended up being minus 5. But what about these weird ones? The answer ends up being the opposite sign. This is the numerator and that is the denominator. See, 1/2, but it changed the sign, negative 1/2. This will be positive 2/3, numerator, denominator, positive 2/3. This one's a regular one. This is minus 1, it's plus 1. So you actually, like if they tell you to show your work, you can, but it's really pretty easy to just know. And how I do it, how I remember it, because it's easy for me to forget which is the numerator and which is the denominator. I imagine the denominator is in a swing, and it swings wee, and it always says wee to go underneath the numerator. Whee! There it goes. Okay, how do you graph this? In reality, you use your graphing calculator. And that's what I want you to do. The book shows you how to do it 1987 style. My time, we did this. You're going to use your calculator graph on your calculator first. You're going to use your calculator graph to get the other graph. It's 2020. We got to embrace the present. Okay? So, first of all, what you do is you look and see what the intercepts are. Now, you would do this. You see that this one is positive 3, and that one's negative 2. So you put your dots there. The thing that you'll probably use your calculator for is the vertex. How you do it 1987 style is you average these two. 3 minus 2 divided by 2. So we add them together and divide by how many we have, which is 2, is 1/2. So we know the x of the vertex is right here at 1/2. But what's the y? We have to take that 1/2, put it back into our original equation, and solve it. 1/2 minus 3 is negative 2.5. 1/2 plus 2 is 2.5. Multiply them together on your calculator, you get negative 6.5. And now we can draw that. But in reality, you're going to do it on your calculator first and work back to that vertex. Okay? Math is great. See you next time.